So we're going to talk about the observer. Well, we're going to talk about design patterns, and design patterns are important. Design patterns, first of all, design patterns, first of all, is not an absolute thing. They're an idea that kept coming back. It's actually rather than an idea, it's an issue or a result of the same requirements coming back every time. So a lot of times, as they make applications, many times that they were doing something, projects or whatever, they had to come and do this specific task, and that specific task was redone so many times over many applications, over many uh, algorithms, that they said, you know what, let's name this thing and let's notify everyone about one of the best strategies and making it happen. Okay, so design patterns are, you could think of it as a strategy uh, for doing something that's reoccurring a lot of times, for doing a special task. And I'm not saying that the task itself is recurring, just for that special task, which comes back a lot of times, we see these design patterns coming to fruition. So coming to being used a lot more. Okay? And again, this is a strategy, it's not absolute, so it doesn't mean you have to directly do exactly step by step how they do it, but more about giving you an idea of one of the best ways of doing it, and you manipulate it for your current task. So at the end of the day, you're going to customize this design pattern to match your needs and requirements. Okay? There's a lot of design patterns. There's books you could go on it, and so forth, so on. There's many of them, but there's two that I want to go through with you. If you're going in web, there would be three of them.
Sir, I think you are not sharing that screen.
Oh, well, I'm not showing anything yet, but correct. Let me
Okay, sir.
share the screen. Well, actually, I am sharing it. There's nothing there to be shared. Um, so there's a lot of design patterns that we're gonna talk about. Um, there's two major ones that I want you guys to know about. Actually, let's go ahead and create some main. So, so let me note down what we were just talking about. So in this, we're gonna talk about design patterns, and they're important because they seem to be coming back again. So the needs for these designs, for these templates, for these strategies, let's say strategies sounds better, strategies, keep coming back. So what they said is, we're gonna put these designs as something public. These four people went together and they found a really good way of doing them, and they gave that strategy to everyone, so it got publicized. Okay, so the strategy in the end is not absolute. So not absolute. Customize it to your needs, and you're gonna see you're gonna be doing that. But at the beginning, maybe you're gonna go directly with the same exact how it's done. But later on, as your projects progress and so forth, so on, you'll notice that these design patterns, they're gonna adapt. Oops, they're gonna adapt to what you need and not what it says. Okay. Uh, so let's get started. So there's a couple design patterns. There's actually a lot. If you go Google this, you'll find many. But the really one that we're interested in at this moment is Singleton. It's going to be a quick one. And another one, which is called the Observer, or sometimes called the Listener design pattern. Okay, so these two, I would like to go through it with you because it's something that recurs a lot, and you're going to see it in a lot of applications, especially this one, Observer Listener. We've already seen it with Swing, the GUI for Java. You're going to see it if you go in Android. You're going to see it if you go in almost anywhere. And I'm going to try and explain this as best as I can, and also this one. And if you're going into web, you might want to think about something called the Builder design pattern. Okay, but for now, we're not going to touch this, but it's something to think about. And there's a lot more. There's template, factory, the facade, the abstract, the builder, the command, and it moves on. There's thousands of these, and again, just someone named them, someone gave you the idea. But to understand, as we're beginners at this moment, to understand these design patterns and why they came to be and how to use it, kind of develops our skills a bit more. So this is a bit important. So let's talk about the first one, Singleton. Now Singleton, what it does, it makes sure that there's only a single instance. If you guys remember the word instance, so only one object of this kind ever to exist. Only a single instance of this object. Okay, only a single instance of this object class. So you cannot. Actually, before we say what we can do, what we can do, give you an example of why we want this single type of stuff. And again, if we run our applications, you'll notice that we have a lot of applications running. And let's say Zoom is one of them. You don't want to have multiple Zoom running because then you might overlap. You might have 2 or 3, let's say, meetings at the same time, and you're in all 3 of them at the same time. Well, there's 3 versions of you in those meetings, right? You don't want that. Give you another example would be, let's say, Creative Cloud. This is Adobe's update thing. Whenever there is a new update for one of the applications, this gets notified, and it notifies me on the screen. Now, if there was 3 of these, well, I get 3 notifications. It's kind of meaningless, annoying actually. And if you notice, a lot of these applications, they take memory, they take CPU, they take disk, etc. So you don't want to take more than you need. Always you want to measure this. So if my application is 3 times over, well then I have 2 meaningless things that are taking my CPU, memory, and disk. Okay. Another good example would be, I don't know, what else do we have down there? So we have Zooms, is this, VPN. Let's say my OBS studio. I'm recording a session. If I have multiple of that recording at the same time, it's gonna double the task on my GPU, on my everything. I don't know if there's any other good example. The best example I use this a lot in work was basically when we want to make sure that the application is unique. There's no other one, and this happens a lot when you're doing updates. So example, updates. So an updater, there should only be one of this. So only one updater gets notified. Only one updater takes care of all this. If there's multiple of this, it's gonna annoy the user and it's gonna overlap and sometimes mess around with things it shouldn't. Okay? So this is important. So in this case, we could create a single instance of this object class. Maybe even sometimes your project is an example, but inside programming, it would be an object class. And how would we want to do that? So let's go ahead and create something. So, sorry. So for a singleton that we're going to create, actually, I want to use one of your assignments as an example, but no, because we're not there yet. So let's do something else. So let's say, I'm trying to think of an example. Give me one moment. What can I create here? Okay, does anyone have an idea of something that should be unique? Okay. So let's go ahead and make some stuff, okay? So we have multiple person. A person, let's say, again, has a private string name, and let's create a class, public person, and it takes a name. Okay, do nothing too crazy, and let's create a getter for that. Generate a getter for that. Okay. Doesn't do really anything. It has a getter. I'm just gonna bring that at the top. and it has it has an attribute name, a getter, and that. So that's fine. So inside main, I could have multiple person. Say person one equals new person, and let's call that person Jason. And then we have person P2, which equals again new person, and let's call that one Janet. All right. So it's pretty straightforward what we're doing. Okay. Seems I got an error. What's my error? There's no error. Let's run it just to make sure. Cool. No errors. I was bugging out for a second. All right. So we got our person. Let's say then we also have a bank account. So let's say there's a bank inside our system. Our bank has an array. Let's say, I don't know, I'm thinking when I'm creating this as we're going. So let's say there's a float array which keeps track of balance, okay? So there is the balance of every user in there. And let's say this balance, we're making it really cheap the way we're doing it, but it's fine. We're gonna do it new float, and it has a size of 10, let's say. And for each one of those balance, we're gonna know who it is because we're gonna associate a array of strings, which is the balance, the balance holder, the card holder, card holder, let's say. And what I'm doing here, it's really badly done, but basically at every position, so at position 0 will match the position 0 of the name. Okay, so both things, they're gonna match. And actually one thing we could do even better is we could have created a map. Should we do that? Why not? I don't want to teach you more at the same time. Let's not confuse them. Well, why not? Let's do it. So we could create this thing called another collection type. It's called a hash map, which takes a key and a value together. So whenever we create a hash map, we have to specify what is the key and what is the value. And the key must always be unique. The value doesn't really matter. So in this case, the key is going to be the person. So every person could have a bank account, a different balance, right? And the balance, I'm going to say the type is going to be float. What's the problem here? Okay, I can't make it primitive, so we keep capital float, which is just an encapsulator for float. And here we're going to say balances. New hash map, we're done. Cool. And the cool part about this, we don't need to specify size. If I didn't do it this way, I would have needed to do two arrays. So one person array. Okay, I was doing it with string before. New person array, specify a size, and if it gets bigger than that, I need to increase it. And I also needed to do the amount of money they had each by doing, actually let's do balance. Let's do amount so it's not too confusing. New float at size 10. This, line 4, is replacing these two. These two require each one to be the same specific position to say that person matches this amount. So at position, let's say 0, it's Reza, or actually we're using Jason. And at position 0 is the amount Jason has, 500. Right? If we go a bit further, position 1 is Janet, and Janet has $2,000. So each position, they were matching that specific person. This is bad. This is a lot of trouble for something super simple. Comes in hash map. Hash map, there is no position 0, 1, 2, or 3, 4. It's more the person is the position, a unique number, a unique identifier. And float is the value. So this is a key value pair. Key value. Okay, and this is important to understand. So this simple thing replaces these two arrays. again, under the helper class to make our life easier. So let's create a bank, public bank. We don't really need anything right now. And let's do a couple of things where you could do at the bank. So at a bank, you could deposit money. So public deposit. But in this case, we need to know who it is that's depositing. So we know the person that's depositing. So the who. And we need to know how much is he depositing. So the amount. And I forgot to put in the return type, in this case for. So here, what we could do is say balance. We could put, the key is going to be the person, so the who, and the value is going to be the amount. Cool? Any questions? Okay. So something to note here is this balance thing has a key value, and this key must be unique, right? So a couple things I said it a couple times, but just to make sure. This is unique. This one doesn't matter, whatever you do, it's up to you. So that one has no rules, okay? But this first part must be unique. So over here, when I add who, I can't add it again because it's already added, right? Sorry. So let's get there. So if I add that number, let's go to main. Let's play around with this a bit. So let's say I have those, and let's say bank. My bank equals new bank. Who cares? And I say bank dot deposit. And I added P1, and then I say 500. This is fine. And if I say bank dot deposit P2, and I say 2000. Right? So far, it should give us no errors. We'll try everything. We'll keep going. Okay. Before we keep going, let's do a bit of stuff with this. So this is currently set to private. I want to display the value, so let's go create a print, public void print inside our bank. Actually, a better thing we could also do is, I like print, but another thing you could do, it's not better, but you could do is overwrite the toString. And that would have been fine too, right? We talked about this before. If you don't remember it, go back to the old videos. Either one is correct. This is more correct because it says what it's doing, while here it's more like I'm printing out the bank object, which doesn't mean to print the balances. Actually, this a better name would be balances. All right, let's get into it. So now I want to go through each one of these balances. I want to print the person and the current amount they have. So we're going to say, I'm going to create a for each. I'm going to say for each. So here we're giving a, here the thing is, our objects are actually this key value pair, right? So even though I'm going through each person in the balance, what I have is a key value pair, and I want to keep it as a key value pair. So I'm going to do key value over here. I think this is the correct one. I don't use Java that much, sorry. Key value is correct, and I need to specify what those key values is. Person float. This is not correct. Import class. No, this is not the correct one. Give me 1 second. One second. Just gonna go through my stuff. Well, let's cheat here, okay? I always say to specify what's the type that's coming in. In this case, we're just gonna creep it as war. Can I not do that either? Damn it, we're using an older version of Java. Give me 1 second. My god, it's not something else. So let's see. I don't want to teach you this either. Sorry, I'm just thinking of the best way of doing this, and I don't use Java on a normal basis to know this by heart. I want to create it for each. Okay, let's do a quick Google. Google Java for each hash map. And we go down. Map.entry. There we go. Okay, so this is what we need. So for each map.entry, this allows you to have a key value pair. So the key in this case is going to be person. The value is going to be float. So each balance, it's the name I'm giving to that thing. For that balance, I know the person and I know the float. N, so this is the Java way of saying N. So for each value inside balances, I want to print this out. What is it giving me error for? What do you mean not applicable? Oh my god, let's bring back that page. There we go. So string hash map selects new hash map string hash map map.entry. I gotta say dot entry set. Okay, there we go. So for each entry inside our balance, this Java is a bit, if you go in a different language, this would be much cleaner. Anyway, balances dot entry set. So for each value inside this array, inside this hash map of person and float, okay, so for each balance I have a person and a float, I want to do something. What do I want to do? Let's go at it. So I first want to, I'm printing a balance, right? So maybe at the top here I would say system.out printing all, let's say bank, printing all balances. And then I would put every person in there. So system.out, let's say balance dot, let's get the key. So remember the key is a unique thing. So key gives me back a person, the return type. And from that person, I want to get his name. So let's put it in multiple lines. So print the name. Print out also his balance. So we're gonna say space. So after the name, there's a bit of space. Actually, a colon. His balance, or let's say, actually, let's put that in a single line. And we're gonna put like this. And in the next line, we'll put a tab plus his balance. So let's say what we're calling balance dot get value, which gives back a float. Right? I hope it's not too weird what we're doing here. So again, remember we're creating a array, in this case, a hash map array. So this is key value pairs. So for each unique person, it will have a float. Remember that the float could be not unique. So Jason could be 500. Janet could also be 500. And the cool part is we could retrieve them back with the person, or in this case, we could go through each person and print it out. So now if we go back to main, and let's say after this, I say bank dot print balances, I should see all the balances that was put in there. The names were not mentioned. What's going on with the names? The balance 500 and 2000 is good, but the name is not. Balance dot get key name person. Here I didn't set the values. This name. Why is this capital? Like that. lowercase, lowercase. So this dot name equal name. So now if we print it again, so we know Jason has a balance of 500 and we know Janet has a balance of 2,000. Stop me at any time. And actually one thing we could do here, after the colon, we could give it a space so it looks a bit cleaner to our eyes. Cool. So let's go ahead and do a couple other things. So what if I did this line multiple times? Let's say 700 and over here I say 300. What would that do? Would it add, which is what are supposed to do, or would it just modify? Well, the thing is, it's going to modify because, again, the person must be unique. So at any moment you call the put, you're replacing the value for that specific unique identifier. So even though I called this 500, 700, 300, it didn't add to the current balance. It replaced it completely. So what we need to do here would be to say put, before we do that, balances, get person, so the who, sorry. So this would get the amount plus add the amount. So this get over here is going to get the value. So in the value in this case is a float, if you notice. So this float is going to get back. We're going to grab that float, add the amount, and now it's going to increase as we go. So if we go and run it again, the amount should be 500 plus 1,000. So 1,500. Unless we get an error. Okay, so the problem is the first time we run this person doesn't exist. So we need to do a couple check. So if balances dot, let's say exist, no, exist doesn't exist, not empty, merge, he said put all, remove, replace, size, values, has, no. So let's say a get. So if we do control Q on this, returns the value to which the specified key is mapped to, or null if this map contains no mapping for that key. So if we do this, and we say this is not null, then we could do this. Else, we could create that entry for the first time. So if the entry is already in there, merge sounds pretty cool. Okay, there's a merge that's even cooler, but for now we'll keep it to this. It's much more readable. So if the entry doesn't exist, if the entry is already there, so it's not null, so there is a person, whoever the who is, we'll go ahead and increase his amount by getting the previous value. This is getting the previous value. This is the part that's throwing our exception, null pointer exception. Does this make sense? Okay, I hope it kind of makes sense. You'll practice. So now if we do it, you'll notice our total is 1,500. Okay, and then we also want to have a, let's say, withdraw. And we're not going to do any of the withdraw. We're not going to do any of the checking if the withdraw is good or bad. Who cares? Again, we're just doing some new theories. So when we're withdrawing, we're reducing the amount. So in this case, we need to make sure that the user exists. If it doesn't exist, it's not good. So here we're going to make sure balances dot get who. So if this is null, so the user doesn't exist, here we're going to return. Usually here you would throw a new exception. The user does not exist. Now, otherwise, you want to take his balance. You want to put his new balance to being, balance dot get dot who minus that amount. So if the user doesn't exist, well, if the user doesn't exist in this bank, return, usually throw a new exception. We simplified it. Otherwise, change the value with whatever it was minus amount. Cool. Let's go back to main. So now we got a bank. We deposit. Let's say bank. We also withdraw from P2, let's say. And we withdraw, let's say, 100. So the final value should be 1900. And we notice it works. Any questions so far? Because now we're going to start making it a bit more complicated, and we're going to add in the Singleton design pattern. Okay, well, bank manipulation shouldn't be done by main. It should be more done by person, right? Well, let's say, not really, but let's say we're just making some design choices in here just so we could get an example to do the bank. So rather than creating the bank here, what we're gonna do, because usually person in real life, they would deposit, withdraw themselves. So inside my person, inside that, we're gonna create a bank, private bank. And everyone's bank could be different. He could be at TD, he could be at whatever, etc., etc. So this time, we have a bank. And for now, we're just going to make it equal new bank. And this time, the deposit and the withdraw is going to be done here as well. So let's make that public. Public void deposit. Actually, let's just go ahead and copy paste that deposit. Just a bit too. So whenever a person wants to deposit or withdraw, they could do it directly. They don't need to say who they are because they are them. They need to say the amount. This whole thing we could remove. And same thing for withdraw. They don't need to say who they are because they are the person. Remember that we're inside the class person right now. So now what they could do is call mybank.deposit, this being who I am, and the amount is amount. Same thing for this one. My bank, withdraw, this amount. Cool, so that's our new person. So deposit and amount, deposit and withdrawal will be done inside the bank. Let's go do one more change inside the print balance of the bank. We're gonna say, here we're just gonna add, I was gonna say add a total. Yeah, let's do it at the end. We're gonna create a float total equals 0. And for each one of them, we're gonna say total plus equal balance get value, and we're gonna add that. And at the end of all of that, we could say cout bank total, and we add the total. Cool? So right now, if we run this without changing the code, it should give me the total inside the bank, which is 1900 plus that, which is 3400. Right? So far, so good. But rather than directly manipulating the bank, this time we're going to allow the people to do it. So the people being P1 and P2, Jason and Janet. So rather than doing this, I'm going to say P1 deposit, and we don't need this. Same thing for these. Let me just do a quick erase. And over here, this was done by P1. This one's done by P2. So far, so good. Well, if I press play right now, what do you think is going to display on my screen? So if I press play, if you thought it through, if not, if you're rewatching this, press pause. If I press play, well, we're printing this bank object over here, but all of these are not manipulating this bank, they're manipulating their own specific banks. So this bank is completely empty. Okay, so you're gonna say it's fine. For some reason this bank is empty, even though we only have really one big bank. We shouldn't have multiple different banks with different values, right? Currently the bank we have here doesn't exist, so we could go ahead and delete it. So this is not existing. Let's go back to our person for a second here. Person has a bank and it's private. Let's make it public so we could just have quick access to it for now. Now, let's say in our main, I say P1, the bank, and print the balance. Is it going to print both people or is it just going to print one of them? P2, my bank, print balances. You'll notice that both of these banks are separate. And both of these banks are only working for one specific specific person. This is not a good thing. A bank is supposed to be shared. How would it know its total if every object is different? In this case, we want to make sure that this bank object that both person have, both Jason, Janet, and more, both of these objects that they have is going to always be unique, right? So we want to make sure that this bank object, you can't create more of it. So this is where the single pattern comes in. So we want to make sure that this bank object should be always unique, so you cannot create it. Because if you do, well, then every person, they have their own new instance of that bank. And every person that makes a bank, they could do whatever they want with it. We don't want to have multiple banks. Then I have to check every bank that exists for their values. No, this is a bad thing to do. Do you guys kind of see my reasoning with this? We want, let me draw a bit. So actually, let me go back to mouse. We want, main, let's say. We want, one more time, drawing. We have one bank instance. Actually, let me change the color so it might be a bit clearer. We want one bank instance. And for each person, say 1, which is Jason. Person 2, which is Janet. Person 3, whoever it is, who cares? We want all of these 3 objects. We want all 3 of these objects to manipulate the same bank object. This is what we're trying to do, and this is called the singleton. We don't want them to each have a single bank of their own. We want them all to access the same bank. So the bank could do something a bit more complex later on, such as, let's say, it could lend money. Well, how would it lend? Well, it needs to have that money from someone else, and then it could lend something it doesn't have. Right? So you could lend the money that person 1 left in bank to person 3. Could, let's say person 2 deposited $2,000. With that $2,000, now the bank could spread it around. I hope this is clear. So, to do this, so let's actually take a screenshot of that. So to do this, sorry, I was taking a screenshot. Okay, so to do this, let's go back to our mouse. So to do this, we want to make sure, so singleton, we want to make sure that we cannot create that object. That object being our bank. To make sure something is not creatable, well, we want to make sure the constructor is not public. Okay? So our first task here, sorry, let me just clear up some skin. So our first task here is to make sure that the bank constructor, the bank object, cannot be created. So the first thing we need to do here is to make it private. Right? And as soon as we do this private, you'll notice person is going to get an error. Hey, whoa, you can't create that object. Cool. Well, what's the issue now? Well, if I can't create the object, how do we get a bank? For a bank to take care of everything. If we cannot create this object bank, we cannot instantiate it. Private, so we cannot instantiate this object. How do we create the object? So this is again where Singleton comes in. Yes, you cannot create the object. This is why we make it private. But the object could already exist and we could hand that object to you. So to do this, the first thing we need to do is to create a couple things. So here I'm going to put Singleton code. Okay, so this is the part of Singleton, and I'm going to end it here. Because we needed other code to make this more readable, and so for so on. There we go. Okay, so the first thing we need is the constructor to be private, so no one could create it. Second thing is we need to give access to this object to everyone who needs it. So we're going to make it public. We're going to make it static, so it always exists without an object. And we're going to make the type become the bank itself. Okay, so now we're giving it the current bank. So we could call it the instance of bank. And what we could do is say equal new bank. How come I could do the new over here and I cannot do it in person? Well, this is because bank is private. But private means it's accessible anywhere inside the class. It belongs to the class. So here it belongs to me, so I could do whatever I want with it. I could create a new object of myself. And it's going to become static, so it's going to always exist. Right? So this is good. So now, again, it's not done, but it's good. So now if we go back to, let's say person, I can't do that, but I could access the static method, bank.instance of bank. And now, if I go back to main and I run this, we shouldn't see two different values at the end. We should see the same number. So actually, let me just not print twice. Let's print only once. When you print the bank balance of all the balances that exist, when you do this print balances, you'll notice it's going to print all of them because person 1, person 2, they share the same bank. And that's what a singleton is. So we only have one single instance of that application. Cool? As always, stop me for any questions because we're going to get a bit more complex. So we created a public static bank and we made the constructor private. So no one else could create an object of bank. But is there any problems with any of this? No one has a problem. The problem is it's our accessors. We're allowing for issues to happen. This instance of bank is public, so we need people to be able to see it. But the problem is, because it's public, it's accessible to be changed and done whatever. So what I mean by this, if we go back in main, and over here I do P1 get my bank, I have access to the value. Or actually, better yet, rather than doing that, what we're gonna do is say bank dot instance of bank. So now I have direct access. I have direct access to my static variable instance of bank. And obviously, I can't create a new bank because it's private. So this is illegal. Okay, that's fine. But did you know I could also set this to null? And if I set this to null, well, those other stuff is gonna break. So let's say if I do this before P1 and P2, well, now the instance of bank, which doesn't belong to main, is gonna be changed to null, and when those person gets created, Well, their thing is gonna say no pointer exception. And again, look at the line I'm saying it, line 16. Bank deposit. Well, the bank doesn't exist anymore. This line where you say bank equal bank dot instance, well, this is returning you back a no value. So it's not a good idea to make this public. This is why we, again, the one we fear is not our users, because our users are limited to what we build. But what we fear is having a big team and the team not knowing how to use our code properly. So they see it's public, okay, well, he's gonna go and change it for whatever odd reason. And again, we might have millions of classes and we don't know exactly where it's being used to change or to be done this or that. And this breaks everything. So this is not a good thing. So this, we should make it private so they can't change the value. And we should create a getter to give them that value. So the getter is not gonna change our variable's value. So here we're gonna say public, give back a bank, right? Actually, we're gonna make this static so it's always accessible, give back a bank. And we're gonna make a function to do that, a method, a getter. So we're gonna say get instance. And notice it's already popping up because it's something that's done with a singleton, right? So get instance or get instance of bank, whichever you prefer. I would usually just go with instance because the class name tells you the value, but for this example, we'll go get an instance of bank to match the instance, the variable name. And over here, all we're gonna do is say return instance of bank. Cool. So now in main, you don't have access to it directly. You cannot set it to null. You could do get instance of bank, but that's pretty much it. So maybe we could do something like here, rather than directly going from a person, we could say bank dot get instance of bank, print me the balance, and this is fine. Notice inside person, this is gonna be bad again. I'm gonna do get instance of bank, and now if we run it, it should be good. Cool. And this is the singleton pattern. Really simple. The only thing we needed to do, 2 lines. Well, a couple lines. We needed to create a attribute to keep hold of that variable, make it static, make it private. We needed to create a getter, so for people to see it but not change it. And we needed to make all the constructors, in this case I only have one, the default constructor, make it private so no one can create our singleton class. And that's pretty much it for design pattern singleton. Any questions? Now, there is 2 things we're not going to cover in this seance. There is something called lazy loading, and there's something called, well, you'll notice them as you go along. What lazy loading is basically this object shouldn't be created until the moment it's required, right? So rather than creating it here, you would mostly create it inside the getter. So the moment someone calls the get method, it's the moment you're going to create the object, and this is useful because if this object is not going to be used until the last minute, you want to kind of wait till that last minute so you don't take away memory space and so on. Okay? And it's not currently within the scope of this course, so we're going to keep it away, but you could look into it. It's pretty simple. Just check inside here. If it's null, you create it. If it's not null, just send it back. Okay. Anyway, so this is the end for singleton design pattern. I'm going to end the recording there.